Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2020 for 2 marks on psychrometry. The question is, moist air at 105 kilopascal, 30 degrees Celsius and 80% relative humidity. Now here the condition at 1, let us say this is the moist air at 1, they have given that here pressure P1 is equal to 105 kilopascal, that is total pressure. Pressure P1 is total pressure, atmospheric pressure, right? Then dry bulb temperature P2 is equal to 30 degrees Celsius and relative humidity Phi1 is equal to 80%, that is 0.8. This is the relative humidity. Now flows over a cooling coil in an insulated air conditioning duct. Now from 1 to 2 there is a duct like this. There is a duct, and in this duct there is a cooling coil. This is a cooling coil, we can say cooling coil, and this unsaturated air is flowing over this cooling coil. This is the flow direction. So they have mentioned that this air at pressure of 105 kilopascal, temperature 30 degrees Celsius and relative humidity 80% flows over a cooling coil in an insulated air conditioning duct. Saturated air exits the duct at 100 kilopascal. Now at exit of the duct there is the air will become saturated, right? Means here at this point 2 the total pressure is nothing but 100 kilopascal. They have given total pressure of 100 kilopascal and 15 degrees Celsius temperature T2 at point 2 is temperature is 15 degrees Celsius and it is saturated. They have mentioned that at exit it is saturated, right? Means saturated means the relative humidity Phi2 will be equal to 100%, right? Then the saturation pressure of water at 30 degrees Celsius and 15 degrees Celsius are 4.24 kilopascal and 1.7 kilopascal respectively. Now here at 30 degrees Celsius they have given saturation pressure and at 15 degrees Celsius saturation pressure they have given. So my dear students, at 30 degrees Celsius it is P sat 1 because 30 degrees Celsius is temperature at 1, sorry, it is a temperature at 1, 30 degrees Celsius is temperature at 1, right, which is 30 degrees Celsius. Therefore P sat 1 at 30 degrees Celsius is 4.24 kilopascal and P sat 2, that is saturation pressure at 15 degrees Celsius is 1.7 kilopascal. This they have given respectively. The molecular weight of water is 18 gram per mole and that of air is 28.94 gram per mole. Now here they have provided molecular weight of air and water, right? For air they have given 28.94 gram per mole and for water they have given 18 gram per mole, right? These are the molecular weights. Then the mass of water condensing out from the duct in gram per kg of dry air is. Now whenever this unsaturated air is flowing from 1 to 2, then because of this cooling some mass of water will get condensed. Some mass of water will get condensed. So they are asking what is the mass of water condensed. This mass of water condensed per kg of dry air. They are asking in gram per kg of dry air, right? So let us do the calculation for finding this mass of water per gram per kg of dry air. Now my dear students, this mass of water condensed is nothing but whatever may be the vapor flowing from 1 to 2, this vapor will get condensed. The air is never condensing, means at inlet and exit the mass of air will remain same, right? Here this capital M is for molecular weight, here small m for mass of air. In both cases mass of air will remain same, but as mass of water is get condensed then mass of vapor will change. Therefore at inlet mass of vapor 1 will be there and at outlet mass of vapor 2 will be there, right? Now so let us find this mass of vapor 1 and mass of vapor 2 at inlet and exit, so that the difference of them is nothing but mass of water condensed, right? Now definitely we can say the mass of water condensed is nothing but initially there was mass of vapor 1 and at final condition there is a mass of vapor 2. So the difference of this vapor is condensed in the form of water. This is the mass balance. So we have to calculate mass of vapor 1 and mass of vapor 2. For this we have to calculate specific humidities. Let us say specific humidity at 1 is omega 1 and specific humidity at 2 is omega 2. So we have to calculate omega 1 and omega 2. Now my dear students, we have given relative humidities at inlet and exit. Right? We have relative humidities at inlet and exit. Now these relative humidity is nothing but vapor pressure divided by saturation pressure. This is a formula to find relative humidity. Vapor pressure divided by saturation pressure. Right. Therefore, if I write phi1, then I will get vapor pressure at 1 divided by saturation pressure at 1. Therefore, vapor pressure at 1 will be equal to phi1 is 0.8 into saturation pressure at 1 is 4.24. Therefore, from this we will get vapor pressure at 1, which is equal to, let us find this vapor pressure at 1, then you will find this equal to 3.392 kilopascal. This will be vapor pressure at 1. And similarly, if I want to find vapor pressure at 2, then I have to write phi2. That is phi2 is equal to vapor pressure at 2 divided by saturation pressure at 2. Right. And my dear students, phi2 is 1. That is 100%. Therefore, vapor pressure at 2 is equal to saturation pressure at 2. Right. So here I can write the vapor pressure at 2 and vapor pressure at 1. Vapor pressure at 1, PV1 is equal to 3.392 kilopascal, and vapor pressure at 2 is nothing but saturation pressure at 2, which is nothing but 1.7 kilopascal. Because already at 2 the air is saturated. They have given phi is equal to 100%. Phi is equal to 100% means PV2 is equal to P sat 2. Right. Now, once the saturation pressures are vapor pressures are calculated, let us find specific humidities, that is omega 1 and omega 2. Now, my dear students, the formula to find specific humidity is nothing but it is a mass molecular weight of water divided by molecular weight of air into PV divided by P atmosphere minus PV. This is the formula to find specific humidity. Therefore, let us find specific humidity 1. Therefore, specific humidity 1 will be equal to molecular weight of water is 18, molecular weight of air is 28.94 into, if I want to find omega 1, then I have to write here PV1 divided by total pressure 1 minus PV1. These formulas we have to write. Therefore, specific humidity at 1 will be equal to, this ratio becomes 0.622 into PV1. The vapor pressure at 1 we have calculated 3.392 kilopascal. Therefore, put here 3.392 kilopascal divided by total pressure at 1 is 105 kilopascal. Right, therefore put here 105 kilopascal minus 3.392 kilopascal. Therefore, this specific humidity 1 will be equal to, if I calculate, then answer for this will be equal to 0.020764 kg per kg. This answer will be in kg per kg. But if I want to convert into gram per kg, let us put here kg per kg. Don't worry, at the end we will convert it to gram per kg. Or here only, if we want to convert gram per kg, then we have to multiply with 1000. Right, to convert this into gram per kg, we have to multiply with 1000. That is 1000 gram is nothing but 1 kg. Therefore, it will become 20.764 gram per kg of dry air. Right, gram per kg of dry air. Now, this is the specific humidity 1. Right, this is the specific humidity 1. Now, my dear students, let us find similarly specific humidity 2. Now, this specific humidity 1 can be written as mass of vapor 1 divided by mass of air. Mass of air is always constant. Here, in this case, mass of air at 1 is equal to mass of air at 2. Right. Therefore, from this we can write mass of vapor at 1 is equal to mass of air into specific humidity at 1. Mass of air into specific humidity at 1. Therefore, here we have calculated mass of vapor 1 is equal to mass of air into mass of vapor, specific humidity at 1, which is nothing but mass of vapor 1 is equal to specific humidities. We have calculated 20.764 into mass of air. Right. This should be the condition. Now they are asking per kg of dry air. Means this dry air mass of air we have to assume 1 kg. At the end we will put as a 1 kg. Right. Now, my dear students, once the specific humidity at 1 is calculated, let us solve for specific humidity at 2. Now, similarly, the formula to find specific humidity at 2 is nothing but, that is omega 2. This omega 2 specific humidity at 2 is nothing but 0.622. Here PV2 divided by P2 total pressure at 2 minus PV2. This is how we have to find. Therefore, specific humidity at 2 is equal to 0.622. PV2 is nothing but saturation pressure at 2, which is 1.7. Therefore, 1.7. Total pressure at 2 is 100 kilopascal. That already we have written. Right. Minus PV2 is 1.7. So if I simplify this, the specific humidity at 2 I will get equal to 0.0107568. It is kg per kg. Now if I want to convert into gram per kg, this specific humidity 2 will be equal to 10.7568 gram per kg. It will be gram per kg of dry air. And this specific humidity 2 is nothing but mass of vapor 2 divided by mass of air. Therefore, mass of vapor 2 we can say specific humidity 2, which is nothing but 10.7568 gram per kg into mass of air, that is kg. Right. So we have calculated here mass of vapor 1 and mass of vapor 2. So let us calculate now the required result. Here we are moving to forward to calculate the final result. Now they are asking, my dear students, what is the mass of water condensed? Now from here at 1 there is a mass of vapor 1, at 2 there is a mass of vapor 2. Now vapor is nothing but water molecules. Therefore, because of this mass difference, the mass of water condensed will be nothing but the difference of mass of vapor 1 and mass of vapor 2. Therefore, we will get mass of water condensed. Therefore, we can write here the mass of water condensed will be equal to mass of vapor 1 minus mass of vapor 2. Right. Therefore, mass of water condensed is equal to mass of vapor 1 is 20.764 into mass of air minus mass of vapor 2 is 10.7568 into mass of air. Now the value is in gram per kg. And my dear students, if I here they are asking gram per kg of dry air. Per kg of dry air means here we have to assume the mass of dry air is equal to mass of dry air is 1 kg. That is per kg of dry air. Therefore, this mass of water condensed will become 20.764 minus 10.7568. So if I calculate this, then answer, that is mass of water condensed, will get equal to near about the result will be 10. The result will be 10 gram per kg of dry air. Gram per kg of dry air. So my dear students, in this fill in the blanks, they are asking what is gram per kg. Then answer is 10. So in this fill in the blanks, if you type 10, then you will get full 2 marks. Thank you dear students. In next lecture we will see one more numerical on this topic.